Okay, welcome to the CDR and Databricks Lunch and Learn. On your screen, you will see two links that I will be pasting in the chat here shortly. You can navigate to them to view previous training resources or upcoming training dates and topics. On to our administrative announcements. Just so you know, this meeting will be recorded and is being recorded. Please try to stay muted to minimize interruptions. And because this session is shorter, it's only a lunch and learn 30 minutes, it will not feature a Q&A section, but at the end of the call, we will be administering a survey. So if you have any outstanding questions that you want to ask the team, feel free to put them in there. And then, of course, we will be putting all meeting materials in the CCSQ DNA portal. Just make sure to give us a few days to turn those around. But with that said, let me go ahead and stop screen sharing and hand it over to Katie.
Hi, everybody. Thank you for joining today. My name is Katie. I'm on the user services team. I'm going to put see if I can find the chat. There it is. I'm going to put this notebook in the chat so you can hopefully see it. And if not, then somebody on my team will go in and fix permissions if it's not working for you. So today we're going to talk a little bit about some sort of looping in Databricks and actually looping in SAS. We're going to look at the data in Databricks. So if you don't know SAS and if macros or some of these things that we talk about are not very familiar for you, that's okay. I think you'll still get something out of this presentation. And we're going to go through a use case where we would do some kind of looping in SAS. One of the things that, and here's what a macro might look like, where in SAS, we typically output a lot of little small files, but we want to do things differently in PySpark. And today, the example that we're using can translate kind of one-to-one from the macro to a Python function. But there is a much more efficient way to do this that we are gonna hopefully cover in a follow-up presentation. So this gets you set up and gets you started thinking about this problem in little steps, one at a time. So we're gonna kind of examine this SAS macro that we imagine we might have. It deals with some nested macro variables. Those, by that I mean the ones that look like this, where you have a multiple ampersands. SAS has to loop, kind of go over it multiple times to evaluate it properly. And the main thing is that I want you to kind of get from this presentation today is thinking through this process step by step in little pieces. So first, and feel free to clone this notebook and change this first cell here. I want you to change this to something that you have access to in your own workbench in your S3, and then this mount path can be changed to something unique for you. And also remember to unmount it, which is something that we do have at the end of this notebook. And in this notebook, we're making a new directory within the mount path, using that mount path to make test 1, 2, 3, 4, just a folder with some unique name so you know it's a test sort of example thing that you can delete. Okay, so for our use case, this SAS macro, I pulled it from a paper that I found, and it was just such a perfect example of how we tend to do things in SAS, where you might have a data step, you maybe have some transformations, lots of things that you do in there, but you're only saving the rows from one, in this case, it's state. So one state at a time, and you're dealing with a lot of little files that you then, maybe you do an analysis on it before, maybe you already did that, and then you output it to some kind of report in the end. So there's sort of like these 3 steps. And the data that we're dealing with today, here's an example of kind of what it looks like. The numbers are going to be different because the example data is created in this notebook, and I use random numbers for these variables. So we have 3 states, 3 counties or boroughs, and then there's 3 variables. So our data are kind of wide, and then we have all the states, we have the counties, and we want to sort these counties by each of these variables And they could be anything. You could, one could be some kind of income, median income, percentage under 18, some kind of ratio of like businesses to population, or I don't know, something like that. These numbers could be anything. Some kind of measure at the county level of things that somebody might be interested in. So this macro, I'm going to say, oh, sorry. I'm going to say that we have a macro called county sort. And it takes one of those variables that you saw. It could be population, percent under 18, yada, yada. And then one state at a time. And then order equals ascending as like a default. Then we sort the data and then we print the data. So let's say that is something like what it does. And then the macro that I actually found online in somebody's report was this macro report. They're looping over two different things here. So we have two nested do loops, and they go to this ampersand, this double ampersand variable J, double ampersand state I. And what those evaluate to on that first pass, just to give you that some context, is that it will become ampersand var 1, ampersand var 2, as it goes through that J equals 1 through 25. So ampersand var 25. And let's say you have some count of population or some count of registered businesses, or, just any kind of the many things you might want to know about different locations. So that's what this part evaluates to. And then this part will evaluate to state 1 through 50, and say state 1 is Alaska, or sorry, Alabama, and then state 2 is Alaska, and so on. So you would probably programmatically generate, these let statements, but they're just here to give you an idea of what we're dealing with in this inner macro. And so what we're going to do is we ask ourselves, what would that look like here in Databricks? We want to use PySpark. So first we're going to create some example data, and it's the table that I just showed you. We have Alabama, Alaska, Arizona, and then I've got 3 counties here, and then a county and a borough, a couple of counties and a borough for Alaska. So we're filling in the data, and I'm just creating random stuff, just some random stuff for var 1, 2, 3. They could be any, variables of interest. And they wouldn't necessarily need to be called var 1 through 3. They're just going to be in a list that we go through. But for example, I'm calling them that so they can be whatever you want them to imagine them. And again, here's the data. So this is what we actually got from the random numbers with this run. This will change every time you run it, but that's okay. It doesn't really matter. The states are here, like you saw before. Counties are here, and then these numbers. We want to order these counties within each state by these numbers, each one at a time. So let me show you first what we're going to get to in the end, and then we're going to work our way through a little at a time, step by step. So we're have our states. So that part where we looped through state 1 through 50, and then the part where we looped through var 1 through 25, these two things here are lists that hold the names of the variables and the states. And that's it. And then remember, we had the macro county sort. And then we're going to do that in here. This is just a data frame that orders those counties with the selected variable. And then we have the report here, which was just percent report. It was a macro. And then we're going to save this to a CSV. And that's important for what we're doing in the sort of optimization part, is taking into account this CSV. And I wanted to note real quick, when you save a file to S3 from Spark, Spark will save it as a folder. So here I have .csv, and this is your path where you're saving to. And var is the name of, basically like the name of the data. So the output path is our S3. That's actually our mounted path with the test 1, 2, 3, 4 on it. And then we create, this saves to a created new folder in S3, a directory called whatever the variable name is. and it contains a CSV in it. And that CSV is, there is going to be one because we say coalesce one. And I say coalesce one because very frequently our users want to save the data to one single CSV because Spark wants to save to as many CSVs as it takes. But you can, if your data can fit in the driver node up into just one thing, basically, you can do coalesce one because that will bring everything into the driver node. It will save it all to one CSV. And that's something I know you guys have seen a lot probably from our training materials where we put this in here, and that's so that you get one CSV. But you don't have to get one CSV, and that's part of the optimization for later. But for now, for what we're doing here today, we're just working through this to make it basically exactly how it is in the macro. And that gets you to getting it in Python, and then there's not a whole lot of changes that you need to make to optimize this after that. So then we do like we did up above with the macro, we're looping through this list of states and the list of variables. But in Python, you just say, okay, for state in states, and that gets me each one at a time. And then for var and vars, it gets each one at a time, population, registered businesses, percent of people under 18, that kind of stuff. And then we use those two functions that we make right here. So next, we're going to work through the solution. And we want to do this in small steps. And we're basically using a subset of data because I've only got 3 states out of all 50, and then I'm only taking 3 counties out of however many are in each of those states. And then to start off with, we are going to just say var1. So if we want to, ask ourselves, how do we replicate what we were doing in SAS? We can just say work with one variable at a time. So let's just go through this sort of use case of our own where we say, I have these data. They look like this, where we have state, county, and var. And in this case, just var1, because we can just start with one of them. We don't have to think about all 25 at the same time. And we might ask ourselves, okay, how do I order those counties within the state? And it would just look like this. So let's say our data frame is called state county DF that has state county var 1, 2, and 3. And we're just going to select state, county, and var 1. Those are the only ones we need for this particular step. And we want to order by state, and then we can do var 1 descending, because in the example they had selected descending as their ordering. So you get the county with the highest population up top, and then you go down from there. So, okay, that's our step 1. So we have this, this that you see right here, where the counties are ordered with these numbers that are in var 1. And here's the largest number for Alabama, the largest number for Alaska, the largest number for Arizona. Those are all at the top. And, you might look at these numbers and say, well, I want to make a report, and these are not very reporty. They're not very pretty numbers. So we want to try and format them a little bit. So we'll take exactly what we had, the same thing that you just saw where we select and then we order by. And then I'm adding another select. And you could, if this was a number, this format number part formats those numbers where you have a comma and 2 decimal places. And that needs to come after you order, because it's not going to order the string in the right order if you put it here. We have to order the actual numeric value, and then we can format the string value that we want for the report. So, and then we give it an alias. Alias just gives it a name that is nicer. So that part covers how to order everything in the way that we want. Next, we want to break them into separate reports, because in our use case, we need these all in individual reports. So for the states, we know we just have 3, so we can put them in a list manually pretty easily like this. And then order equals descending. I did not put this logic in our example, so we're kind of ignoring this and assuming we are just descending doing descending order instead of ascending order, or assuming that all of them are the same. Every report that we're doing is the same order. And then we loop through each state one at a time by saying for state in states. So that selects, for Alabama in states, and then it goes for Alaska in states. We print some kind of thing here, give it a title, and then we're just going to display. We're not even at creating it in a file. We just want to make sure that we're getting the stuff that we want to get each one at a time. So this filter, it's basically the only thing that's really different in this step besides putting it in this loop is adding the filter. So we're just getting one state at a time. So column state equals whatever state was selected, Alabama or Alaska or Arizona, one at a time. And then this creates our tables here, and we get a whole bunch of them. So the next piece is we manually made our state list. We just typed them out, and we were only using one variable at a time. So this step kind of shows you code for how to get that list programmatically. So here we have state, county, DF. That's our PySpark data frame. We're selecting state, so that is still a PySpark data frame with only state. And then we get distinct, so still PySpark, but it's only distinct states because we don't want to repeat. Like in our example here, we have 3 Arizonas. If we have the full data, we would have a lot more, and then every state would have a lot of repeats. So we want distinct to select only just one of those because we only need one in our list. We don't want to make repeat reports. And then here I have 2 pandas. So now we've got a pandas data frame, and I put this in here, but I want to note that please be careful when you use 2 pandas. We don't want to put a lot of different PySpark data frames into pandas data frames because the pandas goes only in the driver node. When you're working with a pandas data frame, this is just going to become a list that we use, and we still can get distributed computing the way that we're using this. And also we're putting something that's very small to a pandas data frame. And then we have to select state from it in this way, because now we have a pandas data frame. And then we go to list. And that means that we get the states in a list. And then this is the list of states, only the states that are in our data, exactly how they appear. And then this is a list comprehension for our list of variables. And it comes out like this, where you have var 1, 2, and 3 in this output down here, where we print each one to see what they look like, just to make sure they look okay. And if you're not familiar with list comprehensions, you can look them up. We also have I have a resource at the very bottom for how to do those. But the reason that we're doing a list comprehension here, because we want to get the list of columns in the data frame, which is what this part does. We have our PySpark data frame dot columns. That's the list of every variable in the data frame. But we don't want, so this says if C is not in state or county. So we're omitting those 2. That's why you see only var 1, 2, 3. Otherwise, you would see state, county, var 1, 2, 3. But you can look this up later. If this doesn't make sense now, that's okay. Just know that this is called a list comprehension, and this is the way that you can get this particular case to look like this. So next, we want to put everything together that we went through step by step. And another thing about doing a subset of data, so when you're working with your dedicated clusters, your personal clusters, you'll want to work with subset data in that. And then you get everything kind of production ready. You go through things step by step, and you figure out exactly how you want things to look and what you want your code to do. And then you can do that in a job. The jobs are very nice. They're lightweight. They're dedicated to your notebooks that you're running in them. And they can take a lot more, they can give you a little more memory. You can usually choose more memory in a job than you can on your dedicated cluster if you need more memory. So that's just an FYI. But now here we have this cell down here, cell 22, that has this thing where we were collecting, we were setting all of our state list and our var list. And then we're going to loop through each one, just like we did in SAS. And here we're still printing and displaying in this example. We're just putting together all this. And this here is just all the pieces that we already looked at one at a time. We have, filter one state at a time from our input data that had all the states and all the counties and all the variables. And then now that we're going for var in vars, we're looping through this list and getting each variable one at a time so that we can, instead of it just saying var1, all I had to do was replace my quote var1 with this variable. So now this will loop through and do all of my reports pretty much how I want them. So this one gives you a bunch of reports because now we're not just doing var1, we got 2 and 3 in there, so we get 9 displays. And I'm just going to go through them, quickly. You see, we've got Arizona. There's 3 counties ordered by this particular variable. And I called it var formatted, but you could put an F string and put your variable in the curly braces so that it gives you the actual name right there. But I didn't run this cell before I changed that. So sorry about that. But that's just a quick, nice little add on for it. And then the next thing we do is we can say, okay, that displays fine. I'm pretty sure if I put it to a CSV, so here's the same thing that we just saw. And instead of it displaying, we're going to put it into a data frame. So data frame equals, and these highlighted parentheses will allow you to put these different pieces on a new line so that it is easier to read. And then at the bottom here, we use that data frame that we just saved with all the pieces that we put together into this CSV. And this is one we talked about above with coalesce one. So we get one CSV. They're each in a folder called the variable and the state. So you can use your path to rename your CSVs and move them into a different folder or whatever you need to do with them. And this is basically it. You could stop here and that would work for you. If you have like, I did a simulation where I had 50 states, 100 counties in each state, and then 100 variables or something like that. And this would not finish. That's too much data. It was like 2,500 reports or something, and this doesn't run very well on that. But in the optimized solution that hopefully I can present to you in a different presentation, this can take a minute, just 1 minute to run all those reports. So I'm going to show you real quick to refactor into a function. And it really is really quick. So if you want to put this into a function, you can, what I can start with is the very bare minimum that you need. So here we have that here. Pass just allows us to have this without an error, have it empty without an error. I paste each piece. So this data frame equals with all of this stuff in here where we select and order things. So we get that little, the table with everything in it, except for what we filter out. And we look at this and okay, I think that could go in the county sort part. And then the report part would be making the CSV. And then, we're not done yet because that's not actually going to do anything. The next step that we want to do is go through each line in our code that we have and think about what would come into the function here and what might our function spit back out that we have to save and work with. So, in this first line, we're creating a data frame. We have to bring one in. So as I would do this normally, I would, copy this, maybe put it up here and then, state, I would copy that, put a comma, put that up there. And then we want to know which variable. So we need the things that are changing and that are coming into the function from outside, you would put in these parentheses here. And if you're not familiar with functions, just, see if you can follow along. We have another presentation on functions that is linked below. And then for the report part, we need to bring in data frame. There's a data frame that we're writing, and we want the path that it goes to, and then this variable and state we're setting to the name of that folder. So we want those up here too. So we take our comments and we add our variables in up here. So we have, data frame state variable. Instead of saying data frame equals, we're going to return this. So what ends up happening is it's data frame equals county sort, and then we specify these things. So this all looks the same as before. We need to know which state and variable, and those things are coming in from outside to right here. And Then for the report, we needed to know this data frame here, the path, and then that var and state that we specify down here. So everything is coming in that we need to use, and we're not returning anything, we're just writing to a file. So then the way that we use those two things is we say data frame equals county sort, because county sort is taking this stuff in, it's doing something with it, and then it's giving us a changed data frame that's in the format with all of the things that we did. And then we put this data frame into our report. We have the output path, variable, and state. And then we still have our loop from before too. So we're able to put all the things together and, kind of piece them together one at a time. And even though this is not an optimized solution, this kind of gets you partway there. And I'm really hoping that we can give you a follow-up presentation where I show you how to optimize this, because I think it'll be really helpful. And then these last two steps, because we saved files in our S3 that we might want to delete, if you kept the output path like what I had above, you should be able to remove it with this. But if you're worried about like deleting something that you don't want to delete, you don't have to run this code right here. You can just go into UFM to look at your S3 and delete. You can select the folder and delete it in there. But this is the code to remove something from your S3. But just be careful that you're using the right folder. And then you want to unmount anything that you have created there for a mount. I unmounted mine, and just in general, please remember to do this because the mounts are all kind of in one place and they don't really go away unless you unmount them. So in conclusion, we walked through translating some SAS code a little bit at a time. We wanted to break it up into chunks, and we dealt with those chunks a little at a time. And there were not very big changes that we had to make when we tried to basically ask ourselves questions, ask each thing as a little question that then we could put together in the end. And that got us from that SAS macro to a Python function that was still using PySpark and our distributed computing so that you can do your work in Databricks. And here are those resources at the bottom, and I'm going to give it back to Laura so she can give you that survey. And please fill out the survey if you can. We love to get the feedback, and feel free to put any questions or suggestions for presentations that you'd like to hear. So thank you very much.
Thank you, Katie. Yep, so I just launched that survey just now. It's only 4 questions. If you did have any particular questions in regards to today's Lunch and Learn for Katie, make sure to put those questions in the survey. And then if you have any suggestions for future topics that you'd like user services to present on that you haven't seen out in Portal, do suggest those also in the survey. And then of course, let us know how we're doing, how we can improve. But yeah, once you take that survey, feel free to drop and have a great rest of your day.